So now let's talk about change in position. When we're talking about change in position, we're talking about what happens when an object moves. Well, we're going to use similar information, similar terminology. So we're going to start with what it is. So, whoops, that's not the eraser. There we go. So change in position, we use this symbol. It's a triangle and an X. The triangle is actually the Greek letter delta. And we measure it in meters, just like we measured the position in meters or some other distance unit. And when we talk about change of position, we're talking about how far it is from where it started. So it was in one place, it's changed its position, and now we got to talk about how far it moved, okay? And so if I look at this picture here, we got A and we got B. Those are 2 points, and there's a line between them. How far is it from where it started, okay? When we find the change in position, this is the formula that we're going to use. So we've got delta X for the change in position. Let me highlight this. Delta X for the change in position, XF for the final position, and XI for the initial position. And the difference between those two positions is the change in position. So I've got an example here. In the picture below, the camera has moved from 5 feet to 8 feet from the sink. How much did the camera's position change? So what I'm going to do is I'm going to take these labels here. The initial position was 5 feet, so I'm going to put this at the 5. And the final position is this 8 feet, so I'm going to put it over here at the 8. So now I've got my final and my initial labeled. So what I'm going to do is I'm going to use that formula, this final position minus the initial position. I'm going to take those numbers and I'm going to stick them in there. So I'm going to be doing the final, which is the 8 feet minus the 5 feet. So 8 feet minus 5 feet. Now, hopefully that's a number you can do in your head. 8 minus 5 is 3, so 3 feet. So I need to check my units. All of those numbers, the final, the initial, and the change in position should have the same units. Do they? Feet, 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 check. Okay, so my units have worked out here. Now, when we're talking about change in position, there's another word that we use to talk about this, and that is displacement. So if you hear the word displacement, it's the same thing. Displacement and change in position mean the same thing. All right, let's look at example 2. In the picture below, the camera is initially at 6 feet and moves so that it's 2 feet from the sink. So let's do the same thing. So let's take our initial and stick it at the 6, and our final and stick it at the 2. Okay, so look, it's going the other direction. So in this first one up here, we were going this. Whoops, that's not the right. Well, fine. We were going toward the 8, and this time we're going toward the 2, which is in the opposite direction. So what is that going to do to our change in position? Well, let's see. So we're still going final minus initial, which means this time the 2 is going to come first. So we'll be doing 2 minus 6. What is that going to do to our answer? Well, maybe you don't like this, but it's going to end up having a negative on it. Negative 4 feet is going to be our change in position. So if we end up with a positive change in position, that tells us that our object is moving in the positive direction. And if we end up with a negative change in position, that tells us that our object is moving in the negative direction. And that is something that is useful in physics because we need to know which way things are moving just as much as we need to know that they are moving, okay? So that is change in position.